Before, we saw how to solve simple equations by adding, subtracting, multiplying, or dividing both sides of the equation by the same number to isolate the variable we were solving for on one side. More complicated multi-step equations can be solved using the same techniques by applying them one at a time. Take, for example, the equation 3x plus 2 equals 14. Now we can subtract both sides by 2 to get 3x plus 2 minus 2 equals 14 minus 2. The 2's cancel here, and we're left with 3x equals 12. Finally, we can divide both sides by 3 to get 3x over 3 equals 12 over 3. Now the 3's cancel, and we're left with x equals 4, which is what we wanted. Notice that to solve this equation, we had to remove the operations on x in the opposite order they were originally applied. If we tried dividing both sides of the equation by 3 instead of subtracting by 2 at first, then we'd be left with 3x plus 2 over 3 equals 14 over 3. Now this equation is even messier than the one we started with, so that doesn't help us very much. Some interesting problems deal with consecutive integers. Consecutive integers are a sequence of integers in the order that you would count them, like 3, 4, 5 are consecutive integers. Consecutive even or odd integers also exist. Those are just consecutive even integers like 8, 10, 12, and 14, which skip all the odd ones, or consecutive odd integers like -7, -5, -3, which skip all the even ones. In a problem about consecutive integers, it is often convenient to assign a variable to the smallest integer. Suppose, for example, that we want to find 3 consecutive integers whose sum is 15. Then we can call the smallest one n. Since the integers are consecutive, the next one will be n plus 1, and the one after that will be n plus 2. Now the sum of n plus 1, and n plus 2 is n plus 1 plus n plus 2, and we can collect the terms here to get 3n plus 3. Now from the problem statement we know this sum has to equal 15, so we now have the equation 3n plus 3 equals 15. Now we can use the previously discussed method to solve this equation for n. Subtracting 3 from both sides, we have 3n plus 3 minus 3 equals 15 minus 3. We cancel the 3's and see that 3n is equal to 12. If we now divide both sides by 3, we have 3n over 3 equals 12 over 3. The 3's cancel here, and we're left with n equals 4. Since we decided that n would be the smallest of these integers, we know that our consecutive integers must be 4, 5, and 6. Now let's check to make sure their sum is actually 15. 4 plus 5 plus 6 is 5 plus 10, if we group together the 4 and the 6, which equals 15.